Hello and good morning and welcome to the CMIP Panel Debate Theatre here at NAB Show 2022. Our opening panel session this morning, the transformation of broadcast media with 5G deployments, and I'll hand you over to the panel moderator, Eric Bolton, VP of Business Development for Zixi. Over to you, Eric.
Thank you so much. Welcome everybody, bright and early on a Monday morning. So this is a panel to discuss the transformation of broadcast media and 5G deployment. With me, I have a very, very relevant group to discuss this. I have Saravanan from Amazon, Dave Parocco out of Verizon, Emeka Akoli from Zixi, and Loic Barbeau, all of them architects in the 5G deployment. So we've been working on a project together that we want to share with you folks, and we have had a lot of lessons learned, and I would say that this group has put forward a lot of things, but you want to hear from me, you want to hear from the actual experts. So we've gone through a big deal with the content and experience. We've launched a 4K channel and a signal. What are the impacts that we have in terms of content architecture? And I just want, Saravanan, why don't you lead us into what that means in the MEC and the wavelength zone, and then we'll work our way through the radio network, through the software, and to the client.
Thanks, Eric. Very fortunate to be here, and thanks for the opportunity to help us to be part of the panel. You know, when we started this journey almost a year back, again, before the journey, you know, just about Amazon, we are building a new service called AWS Wavelength, which is bringing in AWS Edge Compute or AWS compute capabilities inside the Verizon's 5G network in the US. So the idea behind that is, can we give the power of AWS cloud services to our customers inside the 5G network? And if we bring that network and compute and storage of AWS inside the 5G network, what are the different possibilities and what are the different architectures that we can build for our customers to leverage 5G along with AWS network? That's what Wavelength is about. So when we announced this service in 2020, the first Wavelength zone which launched was in Boston and San Francisco inside of Verizon's 5G network. We were looking at so many different use cases. From the likes of AR, VR, immersive streaming, media and entertainment. And one of the cool use cases that we had an opportunity to work together, which is what we're going to talk about today, is broadcast distribution, 4K UHD distribution, using the power of AWS Cloud, along with Wavelength, along with 5G, along with a software vendor like Zixi. That's the power of the combination we are here on the stage to talk about. So this use case about how can we deliver the UHD 4K content in a much more robust and scalable and secure and a cost-effective fashion away from the legacy satellite distribution is what the architecture and is what the solution that we are putting together. So I am immensely satisfied to be part of this panel in a couple of ways. One is representing Amazon in the space of AWS Cloud and media and entertainment, and what it for us to help our customers and partners to build their ecosystem on top of AWS, especially on the 5G edge compute, and also allowing our customers like Bloomberg to leverage that and really showcase the art of possibility of delivering media distribution over not just 5G and edge compute, but over that entire ecosystem of AWS Cloud, all the way from doing media processing and encapsulation and packaging and distributing in a very robust and reliable fashion using our own backbone and then using 5G edge compute is a massive game changer. And that's exactly what we want to talk about today, where we are in the journey, what we have learned so far, and what we want to share with the community in terms of how we can take this further for other broadcasters and other customers to leverage.
Absolutely.
Yep.
So taking that, Dave, from the Verizon 5G perspective, it's been a long journey. Why don't you, I think that's an easy tack on.
Yeah. Well, when we started this, there were 2 wavelength zones. We did an initial proof of concept to test out the infrastructure that we designed initially, and that was like over a year ago. And that we rolled out. We were doing stuff in our New York wavelength zone. It was one of the first things to launch on the New York wavelength zone. And so where the power in this is, from what I'm really excited about helping to design this is it does a lot of different things. Using mobile technology like 5G creates this untethered workflow, right? So while we're talking about distribution here, you can configure this on the fly and be up and running fairly quickly. And the really cool part about it from a performance standpoint is, while we like to talk about hyper low latencies with this, with what we're doing here, what we're also talking about is hyper localization. So you could have the potential to have an exit or an entry ramp for your content anywhere in the country, really. We have 20 locations now. So from a network performance standpoint, over 5G, with the testing that we've done over the past year, we've successfully been able to deliver high quality 4K ultra high def streams through that network, you could go see this live at the Verizon booth. We have it running, and it's on the commercial network, so it's the network you're all using in the building, the self-service here, and we're bringing it in that way so you could see it. But the performance is very good. Coupling AWS with Zixi with our platform, you've got a best-of-breed solution because you're using the power of that edge compute, the power of this hyper-low latency network that's with giving you a localized on and off ramp, and then with Zixi as a way of protecting and ensuring that you have a broadcast quality delivery, is very important.
Excellent. And so Emeka, adding on to this, so we have our cloud, we have our RAN network and backbone, but the software-defined aspect, as chief architect and a man who was in Basking Ridge more than he wanted to be, what were some of the things that you saw within your architecture and laid out, and why is the software-defined element so important?
Yeah. Well, I'll say thanks for our customer and partners. We were able to put our heads together to come up with a distributed architecture using 5G. One of the things on the platform is the agility and also the edge, the intelligence on the edge. So as you acquire content, there are a few things that we learned that needs to be, you need to be on a platform that's fluid, not just for bonding, etc., and things to reinforce the uptime, but also situational changes that might happen unforeseen as you go through the network to your delivery points. So the edge compute is actually important to learn what's happening on those two edges. Distributed architecture, I think redundancy is key, of course, but the mechanism of distributing on the edge and curating the content on the different endpoints that you hand off to is critical on 5G.
And then that leaves our client, Loic, and the man who led us into this great journey. So Loic, from a client's perspective and from a content, obviously Bloomberg Premium, et cetera, and you guys have really led the charge in this. What do you see as these implications from an architectural technical perspective, and why is it important to Bloomberg?
Okay. Well, thank you, Eric, for the intro. Before I start diving into the technical details, let me provide a little bit of information about why we did this in the first place. We all love to play with new technologies, 5G, cloud, that sounds very cool, but at the end of the day, there needs to be a reason, commercial reasons behind that. Bloomberg has a channel that is a 4K channels, and the intention is to be able to distribute that 4K channels to more places in a cost-effective way and in a way that is very resilient. If you look today at what the satellite lets you do, there's a lot of drawback if going down that road. When you start looking at direct delivery over fiber, that may not be as cost effective, and you cannot even distribute it to wherever you want. So we looked at this as a new architecture to have the ability to take our content and easily distribute it. In this case, we focus on MVPDs. So, Fios being one of the MVPDs, but we're looking at, basically all of them. And the intention is to say, well, we can, if we follow that pattern and we reuse that patterns, then we guarantee that we can distribute our 4K UHD channels and we can control it and we can maintain it and we can make it grow. So the task here was to make all of those guys working together to create something. Okay. I'm not going to say it was easy. We didn't put a 5G sticker on a bunch of devices and call it a day. Absolutely not. It was a lot more complicated than that. And if there's one thing that we learned is that the assumptions that we had coming into this were 100% wrong. What we thought was going to work didn't work. And what we thought was going to fail actually was pretty stable. Okay? And when you think about what MEC gives you, the word that was said, I think, 7 times already was latency. Well, we care about latency, but we cared about stability before latency. Okay, when you distribute a live channels 24/7, if you have the best latency but it's not stable, doesn't do it any good. So what we had to put in place is to understand every single layer of the architecture, understand the resiliency, the performance, and make sure that when something fails, well, there is another path of delivery for that stream. And that's basically what we put in place here. Okay, we added nodes, we added instances in different wavelet zones, different paths of delivery, different 5G receivers, different IRDs, and different type of streams as well. When the 5G network gets affected for whatever reason, what is 5G's best friend? Well, it's a 4G LTE. Okay, so we build the capabilities of falling overs to those network as well. Part of delivering it through MEC, you're not going over the regular internet, and that's something that I think is crazy important for us. You are distributing your content over a specialized network that in this case is the Verizon network. So you're not open to everyone to the global internet traffic, but you're going over something that can only be accessed through the Verizon network over 5G or over 4G LTE. From a security point of view, I think that's a big one. And also from a monitoring and control point of view, it's also something that is a much better approach than going over the traditional internet. Okay. In terms of the architecture, do you want me to go over everything, Eric, or do you want?
No, I think you can. I think you're a good kickoff. Why don't you keep going, and then we'll roll it back this way.
So starting from the Bloomberg broadcast center, we have encoders that generate the streams that push those streams to a cloud infrastructure as a ZXC transport stream. From there, we transform the stream in a regular AWS regions. Then we send it to the different MECs, the different wavelet zones for repackaging and distribution and redistributions. So based on where you want to consume that content, you need to send the streams to that specific wavelet zone. Obviously, the wavelet zone that you select needs to be the closest point to where you want where that consumer actually is. In that scenario, we're sending it to the consumer of the stream is Fios in Florida, and we're sending it to a wavelet zone in Miami. So the distance between the headend for Verizon and the AWS wavelet zones is fairly short. Okay, and we are going over the 5G network, but we're using especially the 5G ultra wideband network. That's got the lowest latency and the highest bandwidth. Okay, if that 5G network will fail, we have the ability to fall back on the 4G LTE. There's nothing specific you have to build for that. It's built within the network. Those 5G receivers that we use will automatically fail over from one broadband to from one standard to the other one. But how do you fit a stream that is like this in a network that is like that? So when you have a stream that is 4K UHD, even that we're using H.265 encoding for this, we send 16 megabit streams. When you send 60 megabits multiple times over the 4G network, it's not really that stable. So we're able to actually to also generate an 8 megabit stream that has a that actually works much better over the 4G LTE network, and we use that as a failover. So if there's contention on the network, if there's retransmissions, too many retransmission, it will automatically fall back to the other stream there. So we're using technology that's ZXI to do this. Within the IRDs, we're receiving all the stream as ZXI transport streams with the ability to fall back from one stream from the stream. For a single channel delivery, okay, we have 4 streams that we generate with different paths of distributions. Two of them are 16 megabit streams, 2 of them are 8 megabit streams. If there's contentions, basically we know that there's going to be some switch from one stream to another stream. So the order of switching is based on what is actually being affected. If it's a bandwidth issue, it will go down to the 8 megabit stream. If it's a device issue, then it will stay on the 16 megabit streams. But that was the key. In order to make this work 24/7, we had to use different wavelength zones. We had to use different streams bit rate, and we had to use different receivers on the receiving side in order to process the streams. We've been able to run these streams 24/7 without any interruptions for, I want to say months. And when there was an interruptions, in most cases was because of something that was created by a human, not the system.
Well, that's a good point. So following that through, I think in this architecture, we really work towards redundancy, as you point out, uptimes. Amek, I'm going to kind of roll it back. Start with the software, and why does that matter? Like, think of the visibility and the things we did as we proved this out and measured it, and then I want to come back to Dave and talk about how these, this MEC wavelength zone connection with Verizon, sort of we intermingled. We learned things about that, and then ultimately we'll talk that. Yeah. But Emeka, what did you see as we went through this in terms of the software's relation to the architecture, how it could be redundant, and how it gave us visibility that we hadn't had before?
Sure. Obviously, there are many aspects. You mentioned, Luik mentioned a good point, which is security. So having that ability to have like a DTLS, which is, securing the datagram that's moving across the network is definitely key. So you have certificates on the edges. The other thing I think was clear was you need visibility. You need that telemetry end-to-end across all the infrastructure that it touches. And you also need that instant alarming so you can react and action against those alerts. And if you have a system that's agile, that can situationally change or prescribe on a sequential failover, for example, to another 5G or 4G LTE, then you have that stability and confidence that you can leave it, running for much longer than usual, than say an event, let's say. So now we have a situation where we can run 24/7 with a significant uptime, which is in the high 9s.
So Dave, as we went through this, we can say in full disclosure, we blew up a lot of stuff.
Oh, we did.
And one of the bigger things we haven't really addressed is we as a team went into live linear on 5G, which was not necessarily the most obvious use case to a number of folks. So I think we kind of flipped it on its head. People expect production, they expect contribution, but the delivery and the distribution was a little different. But
sure.
Why don't you help educate our audience on some of the things that we learned as we moved from prosumer to professional?
Sure. So the workload, when you think about it, right, it's a broadcast transmission. So 5G networks or cellular networks that we're using are, right now with 5G, it's more of a, I would say, the radios are sort of, you have radios that are shared right now before, we haven't introduced slicing yet. So with that said, that transmission's coming over, the same radio infrastructure that consumers are using. So there's variability in network performance when that happens sometimes. What we were able to test with, what we were seeing as download speeds, we're seeing download speeds here of like 3 gig. So 3 gig pipe is what we're pulling out of here. Upload speeds of around 100 meg. I think that's pretty impressive. From a performance standpoint, because that workload is a continual stream that's just running on the network. It's not bursty. You're pulling this all the time. the radios and all of the endpoints, there was some tuning that we did. We've learned from this use case as we're rolling out 5G how to tune some of the infrastructure to reflect these types of use cases and support them. We were using on the endpoints of this architecture, we talk about redundancy. One of the things that we've built into it is we're using for what we're showing here and for what we built, and we're running this on for the past couple months, year, this project started. So we're using a fixed wireless access product. So it's basically business 5G broadband, right? That's kind of the service that we're using to do this. In the labs, and out in the field, we're using ruggedized outdoor receivers to do that, and we're using 2 at the location for physical redundancy. And then also what we're doing too is what Luika talked about earlier is with the streams, we're directing the streams that we're able to dictate which streams are going to which receiver. So we're able to bring redundancy into the architecture from the receiver standpoint down to dual switch, dual routers, and then into the plant to IRDs. So there's a lot to unpack there, but that from a performance standpoint, when we started the adventure, we were just doing light loads to test it and tune it, and then we did some load testing, and we were able to get some pretty high numbers out of a radio. We were sustaining almost like a gig. It was like a gig of traffic when we were doing load testing.
Yep.
It was
2.5.
about
2.5.
Yeah. So and that's out of a single location. We were able to see that kind of performance, which was really compelling.
No, that's interesting, and I think what we're trying to highlight here for this audience and video perpetuity is, I don't think it's obvious to the outside world that you need content, you need the cellular, you need the part. And when we first met Saravanan, you were sort of like, why do I need a Zixi?
Yeah.
I mean, so wavelength zone, talk to us about like what you've learned and how that's evolved, because that's the critical component between the regular cloud infrastructure, the radio area network, and how this mesh is going to roll out. So
absolutely, yeah. Thanks for that. It's certainly a great learning opportunity for us when we work with companies like Zixi, Verizon, and Bloomberg to understand what our customer needs are. Right? If you have followed along AWS, it's always been we want to build what our customers are asking for and how we can solve and remove that undifferentiated heavy lifting from our customers' journey. So Wavelength Zone, as you can see, is an extension of AWS Cloud. And more of the media customers, you go around this floor, a lot of them are moving their solutions to make sure that they are virtualized, they are ready to be run in a very elastic compute platform like AWS Public Cloud, and how we can get the economics of cloud to video workflows, right? That's one of the key asks for every customer that you look at today, or every vendor that you want to actually work with. You have a cloud strategy that they already have, right? So from a cloud standpoint, we have been working with the media industry for almost a decade. You see a lot of infrastructure stuff that we have innovated on. We see a lot of the managed services stuff that we have innovated on, working with partners like Zixi to allow them to innovate on our platform. So a lot of innovation from the media industry is already happening in the public cloud. But the idea behind Wavelength is, how can we deliver the edge computing solution on top of what the industry is doing in the public cloud, right? So as you saw what Loic was mentioning, what Bloomberg is doing, Bloomberg has data centers and they have encoders, they have packagers. They're doing a lot of their workload from a data center point into the AWS cloud, right? Most of the content production and delivery is starting to happen from the public cloud. So how can we leverage the power of public cloud with this distributed edge computing platform that we're building is what is all about this particular journey is, right? When we bring these workloads, when we bring the infrastructure into the 5G edge compute, and it's a massive opportunity for delivering these content, not through satellite, but through a purely an IP-based delivery architecture. Maybe a pipe dream, but it is actually a real one, which is we are showcasing right now. Like getting the power of the region, distributing it through Amazon's backbone network into 17 wavelength zone. We are there. We are not there at 20 yet, but 17. We'll be there soon. We'll be there soon. But we have 17 wavelength zone across Verizon footprint, Miami, New York, Washington, D.C., you name all these massive cities, not in the US, but also in the other parts of the world. Think about that opportunity that you have as a customer, you have as an ISV like Zixi, where you bring about the effectiveness of the Amazon managed infrastructure, all the way from 4 regions into 17 wavelength zone, getting you as close to your end customer, which is Verizon's 5G network, and then power that with the capability of what 5G can provide with multi-gigabit of download speed to your end users, right? And most importantly, Loic mentioned about the reliability, right? It's not about 4 gigabits of download or 100 megabits of upload. That is very true. But how can we reliably transport data, especially video data, where packet loss cannot be accepted, jitter cannot be accepted, right? And multipath capability is very, very important. Highly reliable 24/7 type of architecture. We have done a lot of web services based application where packet drop is okay, TCP protocol can handle it, right? But we are looking at a world of media distribution where packet drop is going to literally affect the user experience at the end of the day. And how can we build a very robust, reliable network and compute infrastructure for delivering the content? That's exactly what this group is trying to do and prove to the outside world that it's possible. Visibility is a one important aspect that Loic has been asking from day one. I'm going from my data center into the public cloud, into AWS public cloud, and from there I'm using your backbone into going to Verizon's wavelength zone, and from Verizon's wavelength zone I'm pushing the content into the 5G network, into my affiliates or MPVDs, right? There's so many different components that we are touching. From a network component standpoint, from a routing, from software where Zixi's SDV platform is coming in. Visibility is such a key important aspect that we are building together. Is one of the learnings that we have done is how can we provide a single pane of glass from a visibility standpoint for a customer to look at the health of the streams, to look at how effectively it is being streamed, and more importantly, how to deliver a highly redundant architecture, which is very important for like when I was working with Emica and they looked at their SDV platform and how they bring that software delivery mechanism, a highly programmable infrastructure, so that anywhere there is an outage in terms of connectivity or packet drop or delivery because the packets are being buffered a lot because there is a radio switch or whatever happens on the 5G and LTE network, we need to make instantaneous decision on switching the path. If you looked at the architecture, I think we are going to publish a blog which talks to you about the distributed architecture. It is massively distributed. There is no single point of failure that we have built in. We are leveraging the power of distributed wavelength zone and all the services that AWS has together for monitoring and provide using CloudWatch and other services, extract that data, provide it to Zixi as an SDV platform so that they can view it all the way from where the content is being ingested and where it is delivered. It is key for any types of broadcast distribution. It's already been built. It's not that we are building something new, but distributing it over diverse networks and taking that into one single pane of glass and programming it using AWS APIs through the SDV platform of Zixi, it's fascinating. It's fascinating. I'm not going to say that we are there to production, but we are slowly and steadily getting there to deliver quality 24/7 broadcast content to that entire ecosystem of partners. I'm pretty excited to be on this panel, especially with what Zixi is doing, what 5G Verizon is doing, and with a customer like Bloomberg, I don't think you need any more guarantee that this technology is going to be real and we're going to deliver content for our broadcasters in the future.
The redundancy, that architecture.
Yeah, so Dave, we'll go in there now. We'll just say I'll echo Saravanan's enthusiasm in that what we've collectively put together and we're trying to share with this group is a lot of work. And we've had a lot of learnings. And I think we've established an amazing level of architecture and uptime, and I don't think that it's exactly aware to the outside world of this. But Dave, why don't you just echo on from what we even figured out between wavelength zones, the backbone, RAN. There was a lot in there, and then I want to get it down the thing, and we're going to have probably 8 more minutes. So,
from a redundancy perspective, I'll touch on that. Designing architectures for as long as I've been doing them, since the internet became, started taking off. The architecture reminds me a lot of a financial trading platform's hosting platform. That's how redundant it is. That's what we're doing here. From a networking standpoint, when you're talking to a wavelength zone, You talk to what's called a carrier gateway, and then you hit the wavelength zone that you're going to, and then when you're in that, so that signal path, what you're talking about there from a radio perspective or from a networking perspective, you have the you have the cell tower that you're talking to, the radio that you're talking to. So there's variability there. You have that backbone that comes out of that tower. So there's a feed that comes out of that tower that aggregate, and that goes into a service aggregation point where a whole bunch of C-rounds are connected. That's where these public mech nodes live. And so you, from tower to compute, the latency numbers that we're seeing, we're showing at the booth contribution at 7 milliseconds round trip time. Distribution's tunable. When we were testing it, and reliability is the most important thing. But having, the way I look at it is having that flexibility in terms of latency. So you're building something that, while it's doing something very traditional today, where things are going, maybe it opens up another door on a way to do things, because now you have bidirectionality too. So that's interesting. So from a networking standpoint, there's a lot of piece parts along the way, right from the actual edge devices, the routers that are connected to the 5G receivers that are you're pulling those signals in from, to that radio network, that fiber backbone, and then to the service aggregation point, and then out to AWS. There's a lot there to touch and play with. So it's very complex.
It's a lot. There's a lot of network topology that we traverse. Emeka, can you give us a couple of minutes just saying how we actually have that software fabric? And I want to land on Loic to say what have we learned here in these practices, because you were our fearless leader in this project. So you're responsible.
No, definitely, Loic, because well, I should say, when you have a customer like Bloomberg that's more innovative than you might know, and they are uncompromising when it comes to high fidelity of the content. So here we are trying to push it through 5G, no pressure, right? So that was the task, but I think having the A+ architecture on the AWS wavelet zone and Verizon, we were confident enough. And then you layer on the Zixi fabric. So the Zixi fabric over that network gives you fluidity, and that fluidity allows you to situationally make changes on the edge when you're going over 5G, because nothing is deterministic at the outset. So we have a few efficiencies in terms of payload, bit rates, things like that allows you to fly just under the radar while maintaining the fidelity and the constant bit rate for high broadcast quality delivery. So we're using it to bridge gaps, right? Bridge facilities with the 5G. And if you're going to bridge facilities with A+ networks, it has to be pretty solid and with significant uptime.
And now, Mr. Loic, one of the things you did say is about zero downtime. I don't know what takeaways you want to leave with this audience, but you have the wrap.
So before I get to zero downtime, because yes, when you produce live linear TVs and you have downtime, you're failing. So you need to have in place all the resiliencies that is necessary in order to guarantee that. And to test that resiliencies, we have done a huge amount of work here. I'm talking about pulling cables and receivers, loading the Verizon network to try to overload the radio towers. It was quite extensive. We gathered a lot of equipment in a single locations in order to test some very specific scenarios. So it was a bit of a challenge to do that through COVID, where nobody could actually theoretically get together, but we did it. And we were able to run all of those tests in different locations, the Verizon lab being the main one. Okay. But when it comes to now, delivering, because at the end of the day, you're delivering it to somewhere. Okay, we focus, like I said, on the MVPD, and there's going to be other use cases and scenarios that are coming next, and I'm sure we're going to be sitting here next year again. But for the MVPD, our goal was to create a stack of devices that we can say, hey, I'm giving Fios an example. Hey, you're Fios. Take those devices, take that 5G receiver, you take this. That means you can get our 4K UHD signal there. We guarantee it. We know it's going to work. Okay, and we can go to the next one and do that. Now, when you do those type of things, well, that MVPD, you're not getting into their network, you're not poking a hole in the firewall, in the infrastructures, things that are always very complicated. In this scenario, it is totally an out-of-band infrastructure. They get a cable that gets the video signals, and for their point of view, that's the only thing they should care about. From a monitoring now, and I think that's where we are right now. It's stable. We've got all of the infrastructure, all of the resiliencies that we need. From a monitoring, the Zixi software provide a lot of metrics that allow us to understand the delivery of the streams from beginning to end. I think that there's gathering a little bit more details within the IRDs and maybe within the wavelet zones and correlating all of that. I think that's what is really the icing on the cake that we need to finish here. Okay.
Well, I do think we will be here next year, and I appreciate that. Thank you, Loic from Bloomberg, Emeka, my colleague, Dave from Verizon, and Saravanan from Amazon. We will be back here tomorrow at 3 o'clock on a separate round if you folks want to come in. And the Verizon is showing this live if you want to come take a quick walk down. Thank you, everybody, for your time. Appreciate you on a Monday morning.
Thanks for joining.